So if we take a look at the picture over here, we have two lines, line M and line N, and then we have another line that's crossing over those two lines called line T. So two lines with another line crossing over them right here. What that means is that line T is serving as a transversal. A transversal, we can see, is a single line that intersects two or more other lines. It's like line T is intersecting both line M and line N. Now when that happens, we have four angles created at each intersection. So four angles created at the intersection between T and M, and then another four angles created at the intersection between line T and line N. So what we're going to first do is we're going to look at pairs of these angles. We're going to pick an angle from the first set of four, the intersection between T and M, and we're going to pair it with an angle from the other set of four, the intersection between T and N. And certain pairs of those are going to have specific names. We're going to talk about some same-side interior angles, some alternate interior angles, some corresponding angles, and some alternate exterior angles. And let's jump into that. So first of all, for same-side interior angles, if you look at the name same-side interior, that is really telling you what these angles have in common. So when it says same side here, we're referring to the transversal. So we are looking for two angles that are on the same side of the transversal. So my transversal here is somewhat vertical, so I'd be looking for two angles that are maybe over on the left side or two angles that are over on the right side. Now it also says that they are interior angles. What that refers to is the space that's between lines M and N. So all of this space in here would be considered the interior space, whereas the space that's like below line N or above line M, that would be referred to as the exterior space. So you can see we're looking for two angles that are both on the same side of line T and they're on the interior space. So if I put that together, I'll notice that that angle 3 and angle 5 would fit that category. Angle 3, you can see, is to the left of the transversal, and so is angle 5, and they're both in the interior space. But there would be another pair of angles that would fit that criteria. It would be angle 4 and angle 6. So those are what we call same-side interior angles. A lot of times I abbreviate that as SSI angles. So moving on, now we have a group called alternate interior angles. So just like same-side interior angles, I'm looking for angles that are in the interior space, a pair of angles that are both in between lines M and N. But now, instead of same side, we're looking at alternate, and that means that one is going to be on one side of the transversal and then the other one's on the opposite side. So they're on alternate sides of the transversal. And again, remember, we're picking one angle from this group of four and one angle from this group of four. So let's look at angle 3. Okay, let's pair up angle 3 with another angle that would fit this description of alternate interiors. Well, angle 3 I can see is to the left of the transversal and the interior space. What angle is in the other group of four, but on the opposite side of the transversal and in the interior space? Well, the only one that fits that description would be angle 6. So angles 3 and 6 are a pair of alternate interior angles. There's one more pair, though. If I look at angle 4 is also in the interior space. It's on the right side of the transversal. But then if I look at angle 5 is in the interior space on the left side of the transversal. So angles 4 and 5 also count as a pair of alternate interior angles. Next up, we got corresponding angles, and this one's maybe a little bit trickier. The corresponding in this name refers to as saying they're in the same position. Okay, they're in matching positions. Corresponding can also be thought of as matching, right? So if I look at angle 1, for instance, let's concentrate on angle 1. Angle 1 is like it is to the left of the transversal, but above the line or in the exterior space. I'll just say above the line, I should say. It's to the left of the transversal and above line M. If I move to the other group of four, let's find the other angle that is to the left of the transversal and above line N. So left of the transversal, but above line N would be angle 5. So angles 1 and 5 are what we call corresponding angles. They're like in matching positions among their group of four. You might also think it's like angle 1 is in the top left-hand position among these groups. Angle 5 is in like the top left-hand position among this group down here. So let's look at angle 2. Angle 2 would have a partner that is in its same position. Angle 2 is in like the top right-hand position. It's to the right of the transversal and above line M. And so is angle 6. Angle 6 is to the right of the transversal, but above line N. It's in the top right-hand position among this group. So angles 2 and 6 are a pair of corresponding angles. Angle 3 is in the lower left-hand position, and so is angle 7. So angles 3 and 7 would be a pair of corresponding angles. And then if I look at angle 4, it's in the lower right-hand position among its group, and angle 8 is in the lower right-hand position among its group. So angles 4 and 8 are a pair of corresponding angles. So you can see we actually have 4 pairs of corresponding angles, whereas we only had 2 pairs of same-side interiors and alternate interiors. The last type of angle pairs that we're going to talk about are called alternate exterior angles. And so it's the first time we see the word exterior appearing. Before we talked about interior angles up here. So these are going to be 2 angles that are in the exterior space, so either below N or above M, but they're on opposite sides of the transversal. That's what the alternate means. So let's look at angle 1. Angle 1 is in the exterior space, and it's to the left of the transversal. So now we're going to move to the other grouping. We're going to look for another angle that's in the exterior space and to the right of the transversal, and that looks like it's going to be angle 8. So angle 1 and angle 8 are a pair of alternate exteriors. There's one more pair. It would be angle 2 and angle 7. Again, we can see angle 2 it's above line M. It's in the exterior space up here, and it's to the right of the transversal. And then angle 7 is in the exterior space and to the left of the transversal. So those are a pair of alternate exterior angles. So the next thing we're going to take a look at is what happens when line M would be parallel to line N. So I'm going to put these markings on there to show now that they're parallel. Because when that happens, there are some important relationships that occur between these pairs of angles. And let's start with same-side interior angles. When line M is parallel to line N, so let me write this down. If M is parallel to N, then the first thing we're going to find out is that the same-side interior angles are supplementary. They're going to add up to 180 degrees. So if I come over here and I think about angles 3 and 5 here and here, what I can now say is, so I'm going to kind of separate this out. The stuff that's going to be over here to the left of where I've written the pairs of angles, this is only going to be true if the lines are parallel. But I can say that the measure of angle 3 plus the measure of angle 5 is going to equal 180. And then the same relationship will exist between angles 4 and 6. The measure of angle 4 plus the measure of angle 6 will equal 180. And again, that's only true if the lines are parallel. Now moving on to alternate interior angles, let's talk about those for a minute. The alternate interior angles, if the lines are parallel, will actually be congruent. Alternate interior angles are going to be congruent. Now let me tell you how I know that has to be true. So the first thing I said here, that same-side interior angles are supplementary, that is a postulate. Okay, so that is a postulate. I'm going to kind of start there. I'm going to say this is a postulate, and what that means is it just so happens that it's always true. We can't prove that, we can't necessarily do a geometric proof that it will always be true, but nobody's ever found an example where when the lines are parallel, the same side interior angles are not supplementary. So we just accept that to be true. Now, if that's true, all right, so if angles 4 and 6, for instance, are supplementary, we already know that angles 5 and 6 would also be supplementary because they form a linear pair. Right? 5 and 6 are a linear pair. 4 and 6 we're assuming are supplementary because the lines are parallel and they're same side interior angles. And so now we can see that we would have angle 4 and angle 5 that are both supplementary to angle 6. And we learned in topic 1 that when two angles are supplementary to the same angle, those angles have to be congruent, and they're alternate interior angles. So that's how we can prove that alternate interior angles must be congruent when the lines are parallel, because if the same side interior angles are supplementary, then the alternate interior angles will always end up being congruent based on that idea of what we call the congruent supplements theorem. So if alternate interior angles are congruent, we can come over here and we can say that angle 3 in this picture would be congruent to angle 6. We might write that as the measure of angle 3 would equal the measure of angle 6. It really means the same thing. We could also say that angle 4 is congruent to angle 5, or that the measure of angle 4 equals the measure of angle 5. So those are alternate interior angles. It says that our lines are parallel now, so we know that those pairs of angles will be congruent. Next up, we're going to look at what happens with corresponding angles. Okay, what's true about corresponding angles? Well, let's think about this. We already know that angle 4 and angle 5 are congruent because they're alternate interior angles. We proved that that has to be true. We also know that angles 5 and 8 have to be congruent because they're vertical angles, right? Vertical angles are always congruent. So if angle 4 is congruent to angle 5, they have the same measure, but angle 5 and 8 have the same measure, then it appears that angles 4 and 8 would have to have the same measure, right? And if 3 and 6 are congruent because they're alternate interior angles, right? And angles 6 and 7 are congruent because they're vertical angles, then it appears that angles 3 and 7 would have to be congruent. Then I could go around and do the same thing with angles 1 and 5 and angles 2 and 6. So what it appears is that we can prove that corresponding angles will also be congruent. So in my picture here, again, I can say that angle 1 is congruent to angle 5. I can say that angle 2 is congruent to angle 6. I can say that angle 3 is congruent to angle 7. And I can say that angle 4 is congruent to angle 8. So lastly, we're going to take a look. I'm going to move my screen up just a little bit. I'm going to take a look at alternate exterior angles. What's true about my alternate exterior angles? So I come and take a look here, and I already realize, okay, angles 1 and 5 are congruent because they're corresponding angles. But angles 5 and 8 are congruent because they're vertical angles. So if 1 has the same measure as 5, which has the same measure as 8, then that would tell me that 1 and 8 are going to be congruent. And then if I think about the same thing with, let's say, angles 2 and 6, they're congruent because they're corresponding angles, but 6 and 7 are congruent because they're vertical angles. So 2 is the same as 6, which is the same as 7. That would tell me that angle 2 is the same measure as angle 7, and it appears now that my alternate interior angles are also congruent. And I just realized, sorry guys, I realized I wrote that corresponding angles are congruent, or I'm sorry, are angles here. Well, that's not what I meant to say. I meant to say corresponding angles are congruent right there. I'm sure you guys figured that out. But back to alternate exterior angles, we can say they're congruent. So angle 1 would be congruent to angle 8, and angle 2 would be congruent to angle 7. And I didn't have space up here with corresponding angles to do it, but just remember that when we say that the angles are congruent, what we're saying is that their measures are equal. So I have space right here, so I'll do that. The measure of angle 2 is equal to the measure of angle 7. I could have said the same thing about all these pairs as well, I just didn't have the space to do that.